Hi, I'm Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is an extra resource for anyone who may be needing some help in their chemistry classes. This week, I'm going to be talking about solution dilution and spectrophotometry. I'm so happy to have gotten back after my break. I was just really busy with school and having difficulties with uploading YouTube videos, but I am back now and will hopefully be able to continue with my weekly videos. So without further ado, let's get started. Okay, so the first topic I'm going to be explaining today is solution dilution, which is basically when you use a solution of a higher concentration in order to prepare a solution of a desired concentration. And you dilute the solution of the higher concentration. So you decrease the concentration by increasing the volume, which means that concentration and volume have an inverse relationship. As one increases, the other decreases. So for example, if you add more water to a solution, that will decrease the concentration because there will be less solute in a greater volume. So we can calculate dilution. We can calculate the final concentration or the final volume or the initial concentration or initial volume in a solution given certain information. So the moles of the solute are always going to remain the same before and after the dilution. It's the concentration and the volumes that is what changes. Because no new solute is added. It is just being spread over a greater volume, which we know from our definition of concentration and the equations we use to calculate concentration. So the dilution equation is C1V1 equals C2V2, where initial concentration is represented by C1, initial volume is V1, final concentration is C2, and final volume is V2. Concentration units, are molarity, and the volume units are liters. So you just use this equation and you can calculate any one of the parts of it given other components of the equation. And we are going to go through some problems that are formatted differently so you get a broad understanding of dilution calculations. So first we have if 1.5 liters of a 3.0 molarity solution of NaCl is diluted with water to a final volume of 4.0 liters, calculate the final concentration. So with these problems, I like to label my variables. So this is my initial volume, this is my initial concentration, and this is my final volume. And I also like to always write out my equation first. So I'm going to write C1V1 equals C2V2. And now you can just plug in what you know. So you have your initial concentration of 3.0 molarity times 1.5 liters equals, we're looking for C2, and we have our final concentration of 4.0 liters. Okay, so in this problem, we want to isolate C2. So I'm going to divide both sides by 4.0 liters. And now this cancels out. And if I multiply 3 times 1.5 divided by 4, you get that your final concentration equals 1.1 molarity. You can also write concentration like this with brackets. I would just indicate here that it's the final concentration. Next, we have 200 milliliters of an 0.30 molarity potassium permanganate solution is diluted to a final concentration of 0.25 molarity. Calculate the final volume of the solution and how much water was added. Okay, so my first step, I'm going to convert my volume to liters. So I have 200 milliliters, and that is going to equal 0.200 liters. Okay, so I have V1, I have C1, and then it's diluted, and this is our C2, and it's asking us to calculate the final volume and also how much water was added, which means you're going to have to subtract our final volume from our initial volume. So let's write our equation and plug in what we know. We have, write it over here, 0.30 molarity times 0.200 liters equals 0.25 molarity times V2. And then I'm going to divide both sides by 0.25. This cancels out. And then I'm going to do 0.3 times 0.2 divided by 0.25. So our final volume would be 0.24 liters. So now we want to calculate how much was added. So we are going to subtract our final volume from our initial volume to get the volume added. So that means we are going to subtract 0.24 liters minus 0.200 liters, and we are going to get 0.04 liters added. So now we have answered that question. So that is another format of dilution questions you might be posed. Next, we have calculate the final concentration if 300 milliliters of an 0.50 molarity solution of nitrous acid is diluted by adding 400 milliliters of water. So in this problem, we have to calculate what our final volume is based off of information we're given, and we are also finding final concentration. So we have our initial volume, we have our initial concentration, and this is volume added. So I'm first going to convert everything. The conversions should actually say 1 liter over 1,000 milliliters, not 1 liter over 1,000 liters. I fixed that later in the video, but I just wanted to clear that up. Okay, so we have our initial and how much was added. If we bring our initial and how much was added together, we are going to get our final volume, which would be 0.700 liters. So now we have enough where we can solve for one variable. So I'm going to write out my equation once again and plug in what I know. So my initial concentration is 0.50 molarity. Our initial volume is 0.300 liters. We are looking for final concentration, and we calculated final volume using using the fact that 400 milliliters of water was added. So we can add 300 milliliters and 400 milliliters, convert it to liters, and get our final volume. Now I'm going to divide both sides by 0.700 liters and get that the final concentration equals 0.21 molarity. Remember, this is 2 sig figs because 0.50 molarity is 2 sig figs. In our last example, we have 250 milliliters of a solution contains 10.7 grams of potassium iodate. Calculate the initial concentration of the solution and calculate the final concentration if 300 milliliters of water is added. Okay, so we have multiple things to calculate in this problem. We need initial concentration, and we're calculating final concentration given that 300 milliliters is added to our initial volume of 250 milliliters. So I first need to calculate initial concentration, and we learned that concentration can be calculated by moles over liters. So I need to get both of those units. So we know that we can take our initial volume and convert that into liters. And so there's our liters, and we can take our mass and do a mole conversion in order to calculate the moles. So we have 10.7 grams potassium iodate. That is KiO3. And the molar mass of that would be 39.10 plus 126.9 plus 3 times 16. So in 1 mole of KiO3, there's 214 grams. So I'm going to divide 10.7 divided by 214 to get the 0.0500 moles KiO3. So now to calculate concentration, this is going to be our initial concentration. We can do C equals 0.0500 divided by 0.250, and we get that the initial concentration is 0.200 molarity. So because of the inverse relationship between volume and concentration, we know that our concentration is going to go down if we increase our volume. So that can kind of help us make sure that our answer is correct. So now let's calculate our final volume. I'm going to convert 300 milliliters to liters, which is going to be 0.300 liters. So we have our initial volume as 0.250 liters and 300 milliliters of water added. Our final volume is going to be 0.550 liters. So now we can write C1 V1 equals C2 V2. We have our initial concentration, 0.200 molarity. Our initial volume is 0.250 liters, and then we are calculating final concentration, and our final volume is 0.550 liters. Now we divide both sides by 0.550 liters, and we can multiply 0.200 times 0.250 divided by 0.550, and we get that our final concentration is 0.0909 molarity. And remember that is 366 because of the given values in the problem. Okay, so that is those are the different dilution calculations. I hope I was able to cover all the different kinds of problems you would get, but it's just manipulating these different equations and having a good understanding of solutions and concentrations in order to get you your final concentration and final volumes. So now I'm going to do a quick little description of spectrophotometry, which is something used in chemistry to measure the absorbance of a solution. So to do this, you place a solution of a known concentration into a cuvette, and then that is placed into a spectrophotometer where light passes through it, and basically as the concentration of the solution increases, the absorbance increases because the solution is able to take in more light. So you use your absorbances to create a calibration curve. And then let's say in a problem, you are given a table and you are presented an absorbance and you're asked to find the concentration of that solution with that given absorbance. You can use your calibration curve to help you figure out the concentration. So spectrophotometry connects concentration and absorbance. And it also kind of brings in dilution because as the solution is more diluted and the concentration decreases, the absorbance is also going to decrease. So that is all for this video of solution dilution and spectrophotometry. So I hope you enjoyed this week's video. Next week, I'm going to be talking about dissociation. So I hope you'll join me back if you need some help with that topic. Feel free to leave any questions you have in the comments and I will do my best to answer them. Again, I hope you enjoyed the video and good luck with learning the rest of your chemistry.